Hey everybody, welcome back to another lesson. If you caught that cough that I did just before I started talking, sorry about that. So another lesson, we're on 4.7, and the topic is transformations of quadratic graphs. So this, as you know, is the last week before Christmas break. Everything from this week will go on the next report card, not the current one. Um, you should find this to be a fairly easy topic. So one of the reasons we put it here, we meaning the math department, we plan things out, just kind of an easy topic before Christmas break. It's easy, I say, because it's a lot of stuff we've already done before. We did transformations back in Unit 2. We had several days of that. We've done a lot of graphing quadratics. We used on one day the vertex formula and plotted points, and then on another day we just used Desmos. The goal here is to learn how to graph a quadratic when it's given in this special form down here. This is called vertex form, or sometimes it's called transformation form. And the goal is to be able to do it without Desmos, without a graphing calculator. So that's what we're going to be looking for today. But it should be, again, because it's so repetitive, should be fairly easy. So before I really get into it, here's what I'm going to do. I'm going to graph the parent function. I'm going to do it slowly, point by point, just because. So y equals x squared, that's a quadratic. The graph it creates, as you know probably by now, is a parabola, so it makes this U-shaped graph. But we're going to look at it without anything extra, like no x squared plus 5, for example. No extra numbers in there. So what happens here? Well, I've got this table. I'm going to do it old school. I'm going to plug in the numbers and work it out. So if I plug this -2 in here and square it, -2 squared works out to equal 4. So the point -2, 4 is a point on the graph. Then I plug in the -1. -1 squared is +1. When you square a negative, it turns positive. So -1, 1 is that point right there. Of course, when you plug in 0, you get 0 squared, which is, of course, 0. And boy, that looks just too messy to leave alone. I got to fix that. So 0, 0 is right here. As you know, that's called the origin. Plug in a 1. 1 squared, of course, is 1. So 1, 1 is on the graph. Plug in a 2. 2 squared is 4. And that's up here. And as happened before in an earlier lesson, we have some symmetry here. These two numbers are the same as those two numbers, and that's to be expected. Then you connect the dots to get your graph, and it looks kind of like this here and this here. That's not perfect, but it'll do. So notice the vertex is at the origin. This graph can be shifted right or left or up or down, and that'll put the vertex in different spots. But without any extra numbers, the parent function has its vertex at the origin. I want you to look at a couple of the other points, though, before I just plow ahead. If you start at the origin, the next whole number point is over 1, up 1 in both directions. Over 1, up 1. If you go to the next point from the origin, it's over 2, up 4. Or backwards 2, up 4. So if I move this graph left, right, up, down, or whatever, I know that if my vertex is here, my next point has to be over 1, up 1, and the next one is over 2, up 4. Over 1, up 1, over 2, up 4. When you shift something left, right, up, down, it doesn't change the shape of it, it just changes the position. So things like finding the next point or the next couple of points on the graph is pretty easy. Just left or right, 1, 1, or 2, wow, that was sloppy, 2, 4, 2, 4. So that's kind of some key features here. Oh, also in a previous lesson, I was supposed to bring up a couple of vocabulary terms, and I flat out forgot. So I want to mention this right now, and I'll be carrying it throughout this video. So this point right here, we already said it's called the vertex. Because it is the lowest point on the whole graph, it is sometimes referred to as a minimum value, or a minimum, or a local minimum, or different sort of names. We'll just go with minimum right now. If you have one of these parabolas that's upside down, that vertex is called a maximum. So I'll be asking you to use that vocabulary here as we go through the lesson. So okay, the parent function, meaning that there's nothing added, subtracted, multiplied, divided in, y equals x squared. Vertex is at the origin, it opens upward, which means there's a minimum, and you have these various points that you can plot. As we go into this assignment, we're going to be dealing with transformations. So you want to pay special attention to vertical and horizontal shifts, left, right, up, down. The left, right, up, down comes from these numbers, the h and the k. So h is your horizontal, and it always goes the opposite. So minus is minus is right, positive is left. So let me write that down. Minus right plus left. And then the k here, a number added outside of the parentheses, is vertical shift. A vertical shift. Well, if I could spell that right, that would be awesome. And positive is up, negative is down. Down. There we go. The number in front here of the parentheses that's multiplied does a few things. First of all, if it's negative, that flips the graph upside down. That's an x-axis reflection. Now back when we did transformations, there was also a y-axis flip, but that's not really going to happen with a parabola, because if you flip it this way over the y-axis, you get the exact same graph. So it's not really super relevant. But the other thing about A is it creates a dilation. If you multiply a graph by a number bigger than 1, it stretches it out vertically. So a vertical dilation, a stretch, if A is greater than 1. And if A is between 0 and 1, meaning a fraction like 1/2 or a decimal like 0.3, that shrinks it. That makes it shorter. So just think about yourself. If I could wave a magic wand and multiply you by 2, you'd be twice as tall. Or multiply you by 1/5, you'd shrink down to 1/5 your normal height. Kind of weird, but I don't know. It's a context that might help you remember that. All right, so, and then one other thing. The last exercise is a doozy. I think you'll find this whole assignment easy except for the last one. But there's only one of them, and I don't think you're going to get quizzed on it. So just follow along, do your best on that last one. But for now, let's get started on this. Okay, so notice at the heart of this, the parent function, y equals x squared. Got that? Okay, so how do you graph this? Again, the normal parabola has a vertex at the origin, over 1, up 1 in both directions, over 2, up 4, over 2, up 4, and then you get the graph like this. But when you add the 2 and you add the 3, this plus 2 creates a shift to the left. And this plus 3 creates a shift up. So the vertex, which is normally at the origin, now needs to go left 2 and up 3, and it parks itself right there. For the rest of the points, you don't have to make a table and plug in points. You're probably happy to hear that. I mean, you can if you want to, but if you just remember that the next point is over 1, up 1 in both directions. The next point is over 2, up 4, over 2, up 1, 2, 3, 4, over 2, up 4. And then that pretty much does it for you. Go like this, go like this, and there's your graph. By the way, what type of vertex is this? This is a minimum. So I want to keep throwing that vocabulary at you because I totally forgot to do it on a previous assignment. All right, so what am I expecting of you when it comes to this homework? Do you have to write this in to get credit for the problem? No, I'm going to write that in as part of the notes to help you understand what's going on. You do not necessarily have to write that in. If you want to be super thorough, you can. What I want to see is the graph in the right spot with the correct shape, and please label minimum or maximum. And if you want to abbreviate min and max, that's totally okay. So when you go to check yourself on number 2, it's going to look exactly the same as yours, except you're going to label this minimum. Cool? All right. Please don't use Desmos. That would be super quick and easy, but I want you to actually engage the thought process on this. Okay, number 4. So what we have here is this -2 is going to move our normal parabola, which originally starts at the origin, is going to move it right 2 units. This -2 is going to move it down 2 units. And this negative sign here is going to flip it over. Again, that's called a vertical reflection or reflection over the x-axis. Flip is easy for me to write, so I'm going to write flip. So what do I need to do? I need to go right 2, down 2, and park my vertex right there. And then my parabola, instead of going upwards, is going to go downwards because it's flipped upside down. And to get the right shape, I'm going to go over 1, down 1 in both directions. Then I'm going to go over 2, down 1, 2, 3, 4, over 2, down 4 in both directions. Connect the dots. Okay, I missed that dot, but whatever. And that's definitely a goofy looking line, but fine. Now this point is a maximum or a max. So that's what my answer should look like in number 4. Well, if I scroll down enough, it takes 6 years, so yep, just label that a maximum and it's good. Hopefully, so far so good. You're seeing this as not being a terrifically difficult chore for you to do. All right, next one. This +4 is going to move our graph left 4 units. +2 is going to move it up 2 units. The negative is going to flip it over, and the 2 is going to stretch the graph out. So that might be a little complicated. Maybe not. Hopefully it'll be okay. Let me start with the basics, which is left 4 up 2. Left 4 up 2. My vertex is right there. By the way, just look at this. The coordinates of the vertex are -4, 2. If I take the opposite of this number and that number, then that gives me the vertex. So kind of an interesting little thing there. Not something you have to do, but it's interesting to know. Now my graph is going to be upside down because of that negative, but here's where things change. Instead of going over 1, down 1 in both directions, because this is stretched out by a multiple of 2, it's being multiplied by 2. Instead of going over 1, down 1, I go over 1, down 2, and that stretches it. Over 1, down 2. Just like if it was a rubber band and you were pulling on it vertically, it would stretch out in that direction. Oops. And so the next point, instead of over 2, down 4, I need to go double 1, 2, 3, 4. So I ended up going over 2, down 8, over 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8. Now I didn't double the horizontal. I didn't go over 4, down 8, because that's just a vertical stretch, not a horizontal stretch. Anyway, connect the dots. There it is, and of course this is a maximum point. So number 6 should look just like that, kind of stretched out. And then again, label that a maximum point, and you are good. Let's look at number 8. Here we go. So left 4, up 3. All right, I'm getting really lazy with these abbreviations. So left 4, up 3. There's my vertex. Positive, so this is going to open upward, but it's being multiplied by a half. So I need to shrink this by half. So instead of going over 1, up 1, and putting my next dot, I need to go over 1, up a half. And then the other direction, over 1, up a half. For the next dot, instead of going over 2, up 4, I need to go over 2 and up 2. Over 2, up 2 would take me to there and to there. And so now I get a parabola that looks like it's been stepped on and smushed. It gets wider when you smush it. And of course, this is a minimum value. So when I check this one, it's going to be a wider parabola. And there it is. And again, label that minimum. I really hope you're finding this to be sort of easy peasy. Okay, so this minus 4 is right 4 units. Minus 3 is down 3 units. So right 4, down 3. There's my vertex. Upside down means my parabola is going to go that way. Multiply by a half is a shrink. So over 1, down a half in both directions instead of over 1, down 1. Over 2, down 2 instead of over 2, down 4. And then that's it. And this is a minimum or maximum. That's a maximum. It's the highest point in the whole graph, so call that a maximum. Number 10, right there. And there's our max. Yeah, we're good. All right, number 12. What is that? Remember, opposite of this, you might think negative is left, but the horizontal always goes the opposite of that sign. So it is right 3, plus is up 2. So right 3, up 2 is here. Multiplied by 2 stretches it out. So instead of over 1, up 1, you go over 1, up 2, both directions. Then over 2, up 4 becomes over 2, up 8 in both directions. Connect the dots, you get a very stretched out looking parabola, almost like a V shape more than a parabola, but it is still slightly curved. And the vertex is a minimum value. So number 12, right there, minimum value. We're just cooking right along here. Number 14, so my vertex is going to be right 3, up 1, right 3, up 1. It is upside down, and there is no stretch or shrink. So over 1, down 1, both directions. Over 2, down 1, 2, 3, 4. Over 2, down 4. Ooh, that's pretty bad. Like that. And the vertex is a maximum. Number 14. Yeah, I'm hoping you're getting this. Remember, the last one is a doozy. So if you're like, wow, I've seen enough of these, I am done, please wait till we get to that last one. Or skip ahead to the last one if you're going to do anything. Okay. So left 3, down 1. There's my vertex. Upside down tells me it's going to open downward. Stretched out by 2, multiplied by 2, that means you're going to go over 1, down 2 in both directions, over 2, down 1, 2, 3, 4, 5, 6, 7, 8, over 2, down 8. And it looks like that. Now, keep in mind, this number here, it doesn't have to be a 2. It could have been a 3, so I'd go over 1, down 3, and then over 2, down 12, and it could be even more stretched out. I think that makes graphs that are just so elongated it's hard to do, so the software that I use to put this assignment together only uses 2, and then on the fraction ones you'll see it's always a half. Where's an example? I don't know if you've noticed, but all the fraction ones have been a half. Could be a third or a fourth, and it would just smush it even more, so keep that in mind. Did I check number 16? No, I didn't even finish it. Max. Which that labeling it maximum or minimum, I hope is no severe issue for you. Should be all good. All right, number 18. So my vertex is left 2, up 1. Left 2, up 1 right here. It's right side up, so it is going to go upward. There's no negative there. And then a half. So over 1 up 1 becomes over 1 up a half in both directions. Over 2 up 4 becomes over 2 up 2 in both directions. And we get something like that. I missed that dot, but oh well. We call that a minimum point. So number 18, where am I? Yep, call that a minimum point. There we go. Okay, last one. Change each equation into standard form by completing the square. Remember that. Then sketch the graph of each function. So basically, this is not written in the form ax minus h squared plus k. It's written in the ax squared plus bx plus c form, which is called the standard form. So trying to do everything that I've been explaining to this equation, it just doesn't work. You have to change it into that, and that can be quite a chore. So I'm going to show you how it's done. I'm going to ask you to try the same thing on number 19. It's going to take a decent amount of writing, so I'm going to come down here where there's some space, x squared plus 8x plus 18. Okay, so here's what I'm going to do first. Now normally when we completed the square, one side was equal to 0, and that's not going to be the case here. So we have to do this a little bit differently. Y equals x squared plus 8x, leave a big space, move your plus 18 over here. We're going to fill in, let me change colors just for some variety, this empty space with the magic number. Remember what the magic number is? It's half of this number divided by 2, or half of that number squared. So 8 divided by 2 squared. 8 divided by 2 is 4 squared. 4 squared is 16. That's positive, so I'm going to put a plus 16 right there. But I have now changed the equation. If you just pick any equation and add 16 to it, or add any number to it, you've changed it. And you can't change it. So when we first did completing the square, if we add 16 to one side, you had to add 16 to the other side. You can treat that a little differently when you have a y over there instead of a 0. And what you do is, instead of adding 16 to this side, you just put a minus 16 on the same side. After all, plus 16 and minus 16 is 0. So in essence, all I've done to this equation is add 0 to it. And when you add 0, it doesn't change anything. So you add the magic number, but then right away you subtract the same magic number. Now, for these first 3 terms, you factor them. For the last 2 numbers, you just combine them. 18 minus 16, that's a positive 2. Now if we factor this, x and x, what 2 numbers multiply to 16 and add up to 8? It should be pretty obvious. That's plus 4 plus 4. Now x plus 4 and x plus 4 are the same thing. So when you multiply something by itself, you can just call it a square, and we've completed the square. Now this is in the y equals ax minus h squared plus k, right? It's technically in that form. I know that this isn't a minus sign, that is, but that just means that we use the opposite, which we've been doing on every problem. The a, there is no a, which means it's not flipped over, it's not stretched out or anything, so it's a little bit easier than some of the other problems. But now we can graph this. The vertex is going to be left 4 up 2, left 4 up 2. It opens upward, and there is no stretch, so the next point is over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4. Connect the dots, and we have our parabola, and of course this is a minimum value. Check that number 20, just label that a minimum, and we've got it right. So you've got this in standard form, and you must convert it to vertex form. You're going to need to do completing the square, which we've already done. It's just a subtle change with the fact that you add the magic number and then subtract the magic number on the exact same side. But if you can follow my number 20 as you do number 19, you should be good. If you have trouble on number 19 or on any problem, of course, contact me and we'll set up a Zoom, or I can email you some answers or whatever it takes. All right, I will talk to you again real soon.